2gh equal v power 2. Then I need to take a square root because the v is equal to the square root of the other side. v0 power 2 plus 2gh, and the answer will be this one, part C. Okay. Now,
But Miss, where did you
yes.
get for your fourth step? Where did your 2 come from in front of the G and the H?
Okay, I multiply each term by 2 because I wanted to get rid of the 1 over 2 here. I did skip some steps. Let me just change my color. Okay, what I did, I multiply whole things by 2. Okay, so 2 multiplied by 1 over 2 is gone, so it's 1. The whole things here is multiplied by 2, and 1 over 2 multiplied by 2 is gone. So, and I have this, right? You multiply each term by 2.
But Miss, if you were to divide it by 0.5 from both sides, that would be different, no?
Multiply each term by 2. I didn't catch what you said. Do you want me to do it again?
Miss,
Yes?
I joined late.
Okay. I haven't done attendance yet. Just hold
Okay.
on. Just be here. Okay, I'm gonna
Yeah,
just do it
do
one more
time.
step. Okay. Okay. Maybe it's better. So you agree so far, right? That I can cancel n from each term. True? Now what I have is half v0 power 2 plus gh equal to half v power 2. Agree? And I'm gonna rearrange for v power 2. Means I need to multiply this by 2. I multiply this by 2, yeah? 2 multiplied by 1 over 2 gone. It's gonna be v power 2. And now I'm just gonna multiply the 2 into this bracket. So 2 multiplied by 1 over 2 is gonna be v0 power 2 plus 2gh. Agree? Angelina?
Yeah, I'm good. But for your when you mark the option C as your answer, it doesn't really look like the solution you have. So
Okay,
how
so
would
you
you
see
know?
this is the power of 1 over 2. Now, a square root is the power of 1 over 2, okay? And instead of a square root, I can put it as a bracket and power 1 over 2 because a square root is the same as 1 over 2. This is gone, right?
Okay, thanks. I just wanted to clarify.
Okay, very good. Okay, the next question, what happened to the kinetic energy of the ball when it moves from point 1 to point 2? So it's point 1 to point 2. When the ball is at point 2, it stops, right? So kinetic energy at this point would be 0 because the velocity is 0. Do we have potential energy? Yes. And what is that? Is mgh. What is this h? Is just if I take this to be my 0 level, my h is from here to here, which is equivalent to the 2 meter, right? Now at point 2, I have kinetic energy. I don't know what is the velocity, but this is something I want to find out, right? Later on in the later question, which is half mv2. Maybe I want to find a velocity. And there, I have potential because this is my 0 level. So EP gonna be 0 because H is assigned to be 0. Okay, so what happened to kinetic energy of the ball when it moves from point 1 to 2? See, no kinetic, it turns into, and there is just potential. Potential, it turns completely to kinetic, right? How do I know? See, E total at point 1 is the same as E total point 2. Point 1, I have EK, plus E potential at point 1 is EK at point 2 plus E potential at point 2. Kinetic is 0. I have mgh. Kinetic here is half mv2 and plus 0. See, my potential turned completely to kinetic energy. Okay, so what is happening to kinetic energy? So from here to here, kinetic energy increasing, and completely potential become kinetic. So it's going to be increased. All right. Now, the next question said, what is the velocity at point 2? This is what I have. I can work through it. So I have mgh is equal to half mv2. Mass and mass cancel. Velocity, 2 to the other side is going to be 2gh. Velocity would be square root of 2g multiplied by h. For convenience, I take the g to be 10. 2 multiplied by 10 is 9.8, but let's say I want to make this calculation easier. This is a multiple choice question. It's 40, right? And if I look at the solution, it seems to be, could be the last one, right? The square root of 40. Okay? Just put that in a calculator. Approximately. Okay. Next question. The block 2 gram is released from rest. So I know this is at rest, means the V here is 0. I put it as a 0.1. Let's say this is 0.1, and at the end I put it as a 0.2 top. And I know the H here are gonna be what? 3 meter. There is no friction between the surface and block. And here we have some velocity at the end. V2, we have something, right? And perhaps this is something that I want to find. And the H here is 0. So according to this information, at point 1, I have my kinetic energy should be 0 because velocity is 0. And I have potential energy, for sure is going to be mgh, and my h going to be 3 meter. Here, EK, we do have it because it will have some velocity when it's slide down here, half mv2. And of course, potential going to be 0 because the h is not in here. Now, knowing that E potential, E total mechanical energy at point 1 is equal to the E total at point 2, EK plus EP at point 1 is the same as EK at point 2 plus EP point 2. So EK point 1 is 0, so it's going to be 0 here. EP going to be mgh, and EK going to be half mv2 for the point 2, and the P going to be 0 here. So let's see what the question said. How much work is done? Oh, actually something else. How much work is done by gravitational force on a block? Okay, first, it moving from here to here, right? If I want to find how much work it done, do you remember that the work done that was equivalent to change of kinetic energy? If I know the change in kinetic energy at the first part is half m v 2 power 2 minus half m v 1 power 2. Okay, and I know this is a 2 kilogram block. Under the velocity at point 1 is 0. I just need to have a velocity here. That was the process I was doing, right? Using the conservation of energy to find a velocity here. So mass and mass cancel. Velocity power 2 is 2gh, and velocity is the square root of 2gh. And we know that the g here, I just take it to be 10, and here is 3. So square root of 60, right? Just put it there, is half m. M is 2 kilograms, so put it 2. Square root of 60 to the power of 2 is square root, and power 2 cancel is just 2 and 2 cancel. It would be just 60. and the unit is joule. So I would say this. What is the speed of the block when it reaches the horizontal surface? So we did it is the square root of 60. The square root of 60. Uh, it seems to be that that would be the answer, right? Approximately 7.7. Okay.
Miss, I have a question.
Yes.
For question 7, when you're, you know how you did to find a work, you did difference of kinetic energy.
Mm-hmm.
Can you not also just use like the work formula, like force times displacement and the cos angle?
You could do that. Yeah. Good question. Let me just do that for you guys. Okay. That would be another approach. And this is what you said. That W is going to be, oh, actually, we need to find a force, and it's a gravitational force doing the work, okay? F of G doing the work, right? Displacement, cosine of the angle between these two. True? Now, I know the gravitational force is downward. I know the force is forward. The angle between these two, if this is 30, this is gonna be kind of 60, right? And then FG is mg. FG is mg, and a displacement here gonna be from here to here. So using the Pythagorean theorem, 3 power 2 plus 4 power 2, 9 plus 16 is 25. It's gonna be 5 meter, right? So I know the displacement is 5, and a cosine of what? 60 degree. Cosine of the 60 degree. Let's say this is 30, this is 60. This is the square root of 3, 1, 2. Cosine is going to be 1 over 2. So mass is 2. I just take the g to be 10, approximated. The displacement, we got it to be 5. The cosine of the 60 is 1 over 2. Um, okay. So it seems to be 50. And the closest answer is that, which just shouldn't be that different. Did I make a mistake in here? Because I didn't use my calculator. Let me just use a calculator for that part that I did before here, like especially um no, I did everything right. Okay. So 2 multiplied by g multiplied by h, square root of 60, and then I put that. I just wonder why these two answers are going to be different. It shouldn't be, right? Kinetic velocity have v2. Cannot find a mistake. Maybe I did mistake here. So mass, the force of the gravity is downward. Okay. And that's this um, from end to end. Okay, let me just.
Is it
Mhm.
because you put G as 10?
Oh, maybe. Okay. Oh dear, that's could be. Okay, let me just try it with 9.8. But that would be worse. Um, or maybe here, right? Because this is, I just approximated. That could be true. Okay, let's just do this one as 9.8, and I will see how much my answer would be different, okay? Yeah, because I did approximate it, this could happen when you approximate things. And since it's just multiple choice question, I wanted to do it faster and choose the right, the closest answer. Okay, so that would be square root of 2 multiplied by 9.8 multiplied by 3. Okay. Whew. Okay, so that would give me 7.6688. Still, there is some things there, but it's better now. And if I change this one to 7.668, um, okay, let's see. It's 7.668 power 2 is 58 here. So we will turn to the 58. And I want to just approximate that by 9.8 again, right? No, it's kind of 49. Okay, I'm thinking this could be
Yeah,
30.
I think it's less than 60. Well, the
Start.
cosine is 60.
But Miss, you put displacement as 5, but I think it's 4.
Okay, let me just do that. I did a lot of things in my head, which sometimes. No, it's 5. Because this is a force and this is going to be the displacement, right? The force doing the work is just a gravity, right? It's downward. And this is the force that caused the block move down. And the
But why
displacement is
would
going to be,
displacement? Oh, displacement is downward. Okay, thank you.
yeah. But saying that so, I'm thinking, okay, let me just try this. M2 multiplied by 10, just good 9.8, multiplied by 5, multiplied by cosine of 30. No, I'm sure that would be cosine of the 60. That's interesting. Okay, let's just hold on to that. I'm gonna come back to this one, but definitely you could do this. The answers are close, but still, if I want to do that, if I just take the mg, the force is mg, and I multiply by the displacement in y direction because we can find the component, right? If I do that, what I get is what? Mg multiplied by 3,
Sorry,
multiplied by 3, it would be 60. It would be very similar to what I have here. But I don't know why doing that, because this is Fg cosine. Fg cosine theta will give you the component of your force along the displacement. It should be the same, honestly, when you are multiplying by actual d. Let me quickly again think about it. That would be interesting. Just thinking about the angle between the displacement and angle between the force, which is downward, I think that would be 60. Something is definitely I need to check in. Okay, let's just move on. Don't spend time on that. But that is something I can promise you is correct. The answer would be 60. Okay?
Sorry, Miss.
Yes?
I have a question. Like, why, like, uh, like, W equal E, okay, and Y minus, velocity,
So work,
minus.
okay, that's a law. Work is equal to change in kinetic energy. We did prove that in a slides we did on Tuesday. The work is equivalent to the change in kinetic energy. Remember that? And changing kinetic energy means kinetic energy at point 2 or final kinetic energy minus kinetic energy at point 1.
Oh, yes. Oh, sorry, so sorry.
No worries. Okay, so let's just move on. I'm gonna just check this formula back to see why this is kind of not matching. That would be something that really I'm interested to see why this should be the same, right? Because the only force is gravitational force, and we have a displacement along this axis, and the angle between the force and displacement, I think it should be 60. Okay, but let's just move on. Now, what is the total mechanical energy of the apple with respect to the ground? when it is at the edge of the cliff. Total mechanical energy at this point, E total, is equal to EK at this point plus E potential. See, this apple it doesn't have a vertical velocity, but it has a horizontal velocity, right? So it is half m v0 power 2. And it has some distance from the surface of the earth, so for sure it's going to be mgh. So if you want to find a total mechanical energy, that would be, and you can show half mv02, that would be the answer, okay? What is the kinetic energy of the apple just before it hit the ground? Okay, kinetic energy, right? So again, when it hit the ground, we do have kinetic energy, which is half mv2. And we have what? Potential energy is 0. I know that the total energy, that was 0.1. Let's say just put as a 1 here. And here is 0.2. Total energy at 0.2 is EK plus EP. I know I do have some EK, but I don't have EP. So I know the total energy at 0.1 should be the same as total energy at 0.2. Half mv0 power 2 plus mgh. It's equal to EK at 0.2, right? So just is mgh half mv2 here. Okay, yeah, okay, this is addition, right? If you ask to find the velocity, it didn't ask, but if you ask to find the velocity, and instead of this EK2, just replace it by half m v2 power 2, so they equal them. So half m v0 power 2 plus mgh equal to half m v2 power 2. Cancel the m. Multiply each term by 2. v0 power 2 plus 2gh. v0 power v2 power 2. So the square root, that would be the velocity. Here is the last one, right? Question 8, 9. Okay. A 500 kilogram roller coaster car starts from rest. So here we have a velocity at point A to be 0. Move down the vertex track as shown. Assume the track is frictionless. Find the speed of the car at the lowest point B. So here I want to find the speed. I know that the h here, h at B gonna be 0, h for A gonna be 45. So total mechanical energy at point A is equal to the total mechanical energy at point B. So that would be half mv power 2 at point B plus mgh at point B. Oh, sorry, I just want to set A because I put A first. Is equal to half mv power 2b plus mgh point B. So again, I can cancel masses, right? Each term. And I do not have velocity for point A, so that term would be 0. What else? I do not have HB, so that term is 0. I'm just gonna write it down. GHA now is equal to half VB power 2. This point you can sub the numbers, but I like to rearrange further. A is equal to VB power 2 square VB is the square root of 2GHA. Okay. 2 multiplied by 10 multiply H 45. It's gonna be 900. It's gonna be 30 meter per second. So that would be the answer. Find the speed of the car when it reaches point C. So for point C, I'm going to use the different color. For point C, I want to find the velocity, right? I know some h is there, which is 25 of kinetic and potential here. So to do that, I can take my point 1 to be B or A, doesn't matter. Let's just put this one to be the first one and this one to be my second one, right? Total, maybe just put that here. E total for point A should be the same as E total for point C. Okay, again, 2 points, just mechanical energy should be the same. So for point A, so we have half m VA power 2 plus m GHA plus or equal to half m VC power 2 plus m GHC. Okay, so because the velocity at point A is 0, so this term is gone. H here, H we do have some H, right? You cannot get rid of that. I can divide each term by mass, so I'm getting rid of each mass here. So GHA is half VC power 2 plus GHC. I'm looking for VC, just bring everything one side. GHA minus GHC equal to half VC. I multiply each term by 2. So 2GHA minus 2GHC is VC, and I forgot this power 2 here. Take a square root. VC is equal to square root of 2GHA minus 2GHC. I'm going to put these numbers. 2 multiplied by 10 multiplied by 45 minus 2 multiplied by 10 multiplied by 25. So that would be 900 minus 500. That would be 400. Will give me 20 meter per second. Okay, so that would be answer B. Okay, any question?